The first type of series we're going to look at is geometric series. And a geometric series is just whenever you add up a geometric sequence. So let's see if we can figure out how we can know when this converges or diverges. Well, Sn is going to mean A. My initial to rearrange this so that I have Sn minus Rsn is equal to A minus Arn. I'm then going to factor both sides. Sn is 1 minus r. And then on the right, A times 1 minus r to the n. And then I'll divide both sides. So now the question is, why did I go about doing all of this? Well, a geometric series is just taking the limit of this as n goes to infinity. So all I need to do now is take the limit. If I take the limit as r goes to infinity, I'm going to have two things happen. First, if the absolute value of r is less than 1, then that r to the n term is going to tend towards 0. So then I'm going to have that my sum from k equal to 0 to infinity of ark is a over 1 minus r. And if that absolute value of r is greater than or equal to 1, then my series is just going to diverge. So now I can find the results of geometric series very easily. In fact, if they converge, I can tell you exactly what they converge to. Let's look at some examples. Here's a geometric series, and whenever I have these, I need to figure out what a is and what r is. A is always going to be the first term in the series, in this case 1/2. R is then what I multiply by each time. 1/2 times 1/2 is 1/4, times 1/2 is 1 over 8, times 1/2 is 1 over 16. Since the absolute value of r is less than 1, this will converge. And I had a formula that said a over 1 minus r. So 1/2 over 1 minus 1/2, and once we simplify that, we get 1. So this thing will add up to be 1. My next example, 1 plus 1 over pi squared plus 1 over pi to the 4th plus 1 over pi to the 6th, etc. A is always the first term, and then r is what we multiply by each time, which in this case is going to be 1 over pi squared. This is less than 1, so we're going to converge. And I have a over 1 minus r. So now I have this formula for when this converges. We can make this a little bit nicer and write it as pi squared over pi squared minus 1. My next example, 3 plus 6 over 5 plus 12 over 25 plus 24 over 125, etc. A is my first term, which is 3. And to get from one term in this series to the next, we need to multiply the top by 2 and the bottom by 5, so 2/5. The absolute value of 2/5 is less than 1, so this converges to a over 1 minus r, which if we simplify is 5. So this series converges to 5. Here I have it actually written in summation notation, but this is the sum from 1 to infinity of 2 to the 4/5 k. So in this case, a is 2 and r is 4/5. So it does converge. We have a over 1 minus r, which is 10, but I claim that 10 is not actually my answer. My summation formula originally said that we had to start at k equal to 0. And this series did not start at 0, it started at 1. So I've added in an extra term here. This is actually equal to 2 plus 2 times 4/5 plus 2 times 4/5 squared, etc. However, the summation that I want starts at 1. So this is 2 times 4/5 plus 2 times 4/5 squared, etc. So you can see I added in this extra 2 term originally. So my actual answer is 10 minus 2, which is 8. What about this one? Well, a is the first term, which is 1, and r is what we multiply by each time. We're changing sign each time, so we're going to be multiplying by a negative 2. And this is going to diverge because the absolute value of negative 2 is bigger than 1.